Good morning, students. Last class we learned about Newton's universal laws of gravitation. First we can revise the definition. Every particle in the universe attracts every other particle with force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now, a final expression F equal to G into M1 M2 divided by R square. What is the value of G? 6.673 into 10 power minus 11 Newton meter square kilogram raised to minus 2. What is the unit of G? Newton meter square kilogram raised to minus 2. So, I hope all the students you all learned well. I hope very important question. The value of G also very important. You have learned well. Okay, students. Today we can learn about force, types of force, resultant force, rotating effect of force and moment of the force. First of all, we can learn about force. We hear the usage of this term many times in our day-to-day life. We might not using it, opening a door, riding a bicycle, lifting an object or few of the most common things perform in our daily life. And all these require a force. What is the force? Consider a ball lying on the floor at rest. It's not moving. Suppose this player here wants to pass this ball to a teammate who standing on the other side of the pitch. How will you do that? He needs to make it directed of the teammate. So he will kick the ball in the direction of the teammate. When he hits the ball, he said that he applied force on the first ball. It is nothing but is the force applied on the ball. And suppose we have a desk here at the point A. A person wants to move this desk from point A to this point B. Again, how will you do that? Here, he will push the desk towards the point B. In this case, we say that the person applied a force on desk in order to shift it. Push here is the force applied on the desk. Similarly, you lift an object from the table. We say that you applied the force on that object. Here, the force is applied in the form of lifting. So, force is nothing. Action such as kicking, pushing, lifting, etc. perform on an object. There are such many actions that we can perform. We have already seen few of these, some more of them given below. While riding the bicycle, you pedal it continuously to keep its motion. Here, pedaling is the force applied on the bicycle. Hitting the hammer on the nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball is the force applied on it. Opening a drawer, plucking a string of the guitar, moving a piece of a chessboard, or some of the other actions performed on other object. So, performing these actions on the object is nothing to apply force on them. But these are hands. So many actions as we can perform on their object. It is not possible to write each of them. We can categorize all these actions in the turn basic one. That is, we can describe all these actions and to write each one of them. We can categorize all these actions in turn of basic one. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we are lifting the bucket of water from the well, passing the football, hitting the hammer in the nail, etc. So, moving an object can be described at a force. Similarly, opening or shutting a door can be through us, that is force. From this video, you have understand about force. Force is an external effort in the form of pull or push. Next, we can see the effect of force. What are the effects of force? First effect, force tries to produce the motion of a static body. Point, force tries to stop a moving body. Third point, force tries to change the direction of motion of a moving body. So, force has both magnitude and direction. So, force is a which quantity? Vector quantity. Okay, vector quantity means what are all there? Magnitude and directions are there. Totally, we have learned about 3 effects. What are the 3 effects? First one, tries to produce the motion of a static body. Second one, tries to stop a moving body. Third one, tries to change the direction of motion of a moving body. So, force has both magnitude and direction. So, it is a vector quantity. Okay, first we have learned about the force definition. What is the force? Force is an external effort in the form of push or pull. Next one is types of force. See, based on this direction, the force can be classified into 2. So, 2 types. One is like parallel force and another one is unlike parallel force. Now, can you say what are the types of force based on this direction? Like parallel force. Next one is unlike parallel force. Now, your book page number 3, they are given types of force. What are the types of force? Like parallel force and unlike parallel force given. So, see here, like parallel force, 2 or more force, equal or unequal magnitude, acting along the same direction parallel to each other is called like parallel force. Okay. Unlike parallel force, what difference means? Other everything same, but here instead of same direction, here what will come? Opposite direction. Okay. First we can learn about like parallel force. 2 or more force, equal or unequal magnitude, acting along the same direction parallel to each other is called like parallel force. Okay. See here, 2 or more force. 2 force we can act or more force also act. Equal or unequal magnitude. Magnitude equal also or unequal magnitude, acting along which direction? Same direction parallel to each other is called like parallel force. Okay. Like parallel force all of you know now. So, 2 or more force, equal or unequal magnitude, acting along the same direction parallel to each other is called like parallel force. Okay. After that we can see the example. Now we can learn that definition for like parallel force. You should understand this. So, what you have understand? 2 or more force, equal or unequal magnitude in same direction. So, that's really important. Same direction parallel to each other is called, what is that? Like parallel force. Okay. Next one, what is that? What is the type? Next one, unlike parallel force. So, first itself I told the difference. Like parallel force, unlike parallel force, what difference is there? You know all of you. Here same direction means there what? Opposite direction. See here, if 2 or more equal force or unequal force act along opposite direction. Now see the arrow mark, opposite direction parallel to each other, then they are called unlike parallel force. Okay. See, if 2 or more equal force or unequal force act along opposite direction parallel to each other, then they are called what? Unlike parallel force. Okay. Now you have know about like parallel force and unlike parallel force. What difference you have find out? Here same direction, here what? Opposite direction. So you can see in that picture opposite direction arrow mark. Did you see the opposite direction? So, here 2 or more force acting in opposite direction is called unlike parallel force. Once again, we can learn this like parallel. There are 2 types of force. What are the 2 types? Say students, what are the 2 types? Like parallel force and unlike parallel force. Now, we can learn about like parallel force. 2 or more force, equal or unequal magnitude, acting along same direction parallel to each other is called like parallel force. Okay. The next one is unlike parallel force. See, if two or more equal force or unequal force act along opposite direction parallel to each other, then they are called unlike parallel force. Now you have understand about types of force. Types of force. What are the types of force? Two types, like parallel force and unlike parallel force. Parallel force and unlike parallel force. Next one is resultant force. In book page number 3, the resultant force. Now close your book and listen here. We can learn about resultant force. We can imagine there is a cupboard on the roof. The first person came to push the cupboard with 50 Newton. The cupboard doesn't move. Then second person came with 7 Newton. The cupboard doesn't move. Then third person came with 5 Newton force. All forces combined together 15 plus 7 plus 5 to form 27 Newton. This combined force is called resultant force. This resultant force helps the cupboard to move or not. Yes, the cupboard starts to move. From this, we can conclude that 3 or more forces acted along same direction. The resultant force is add plus. That you have to add all the values. For opposite direction, we can see other example. There in the cave. Inside the cave, there is a treasurer. There are 2 boys fighting for the treasures. The small boy is applying 4 Newton force and the tall boy applying 10 Newton force. Can you guess which side the treasure moves? Yes, we know that it moves right side. Do you know why it moves right side? There are 2 forces, greater force and smaller force. These 2 forces are applied by the body through opposite direction. So, resultant force for opposite direction is to subtract. Greater force minus smaller force. Here, greater force is 10 Newton. Smaller force is 4 Newton. So, we have take difference, that is subtract, we will get 6 Newton. 6 Newton is the resultant force. But, which direction 6 Newton force applied? Through the greater force. We can conclude that 6 Newton is applied through the right side. 6 Newton is the resultant force. The direction is through the greater force side. In the first case, the 3 boys applied force through the same direction. So, we add, in this case, the force is through the opposite direction. So, we have to subtract. Then look at the tabular column. First column, parallel force are acting in the same direction. Same direction, the force F1 and the force F2, 2 are in same direction. So, we have to add. So, resultant force F1 plus F2. The next one is parallel unequal force are acting in opposite direction. Now, look at this picture. Here F1 and F2, 2 are in opposite direction. Now see the resultant force, which force is greater, that only you have to write first. So first here given one condition, F1 is greater than F2. So you have to write F1 minus F2. Next F2 is greater than F1. So you have to write the formula F2 minus F1. So the F resultant is directed along the greater force. See, look at this. Which force is greater, that only you have to write first. So, or F resultant equal to F1 minus F2. Why we have to write F1 minus F2? F1 force is greater than F2. Next, see F2 minus F1. So, which one is greater? F2 is greater than F1. So, we have to change this formula F2 minus F1. So, here the resultant is directed along the greater force. Next one, parallel equal forces are acting in opposite direction in the same line of action. See, the action is same as F1 equal to F2. Look at this picture, F1 and F2. Both are given same force. So, you will get F resultant equal to F1 minus F2. This formula. So, F1 also, suppose 5 Newton. F2 also 5 Newton. So, 5 minus 5, what answer you will get? Resultant force is 0. Since F1 equal to F2. So, both are equal. So, you will get the resultant is 0. See, look at this tabular column and learn how to change the formula. So, which side the greater force is there, that will you have to write it first. Okay, students. So, F resultant equal to F1 minus F2. Suppose same direction means you have to add, opposite direction means you have to subtract. Page number 4, in the book it is given this tabular column as well as this definition also given. So you have to learn. Now we can see some examples. Imagine in the village there is a well. A boy is going to fetch water from the well. Inside the well there is a force of 15 Newton. It moves downwards. It is by gravitational force. The boy is applying 10 Newton force. If the bucket comes up, imagine it. No, the bucket doesn't move. 15 Newton is greater than 10 Newton. So, in the bucket did not comes up. In this case, the resultant force is in opposite direction. So, we can subtract. So, which and all you have to subtract? 15 Newton minus 10 Newton. What answer you will get? 5 Newton. So, the bucket moves downwards. In next case, the boy is applying 15 Newton force. Is the bucket moves? It doesn't move, it stops there because of the equal force in the opposite direction. So, it stops. The resultant force is 15 Newton minus 15 Newton. So, you will get the answer is 0. Both the forces are same. So, you will get the answer 0. So, in this case is equilibrium state. Why equilibrium? Because you will get to the 0. If any force that gets 0 Newton is called equilibrium. At first, in 15 Newton force, the bucket moves downwards. When the boy uses 15 Newton force, we stops in the state of equilibrium. The boy uses 15 Newton force. This force is called equilibrium force. So here both the forces are equal. So we are saying as equilibrium force. Y means we will get to the answer is 0. So we are saying this force is equilibrium force. Next one, the boy applies 20 Newton force. First we have learned, the boy applied how many Newton? 10 Newton. Second one 50 Newton. Third one 20 Newton force. The bucket comes up because 15 Newton is less than 20 Newton. So, the resultant force is 20 Newton minus 15 Newton. You will get answer 5 Newton. 20 Newton is the greatest force. So, the resultant force acts on the greater side first. So, the bucket comes up. We have saw 3 cases. In the first case, bucket through downward direction. The second case, it sucks. The third case, the bucket comes up. The first case and third case is called unbalanced force. The unbalanced force, the resultant force should not be 0 and it causes the motion of the body. In the second case, equal force is applied. In the second case, equal force is applied, so it is called balance force. It is balanced force. Resultant force equal to 0 and it causes the body to be the line rest. It is called balanced force. So, now you are clear about balanced and unbalanced. Look at this problem. For you, book by question, Rome letter 6, question number 3. Now listen all of you. If a 5 Newton and a 15 Newton force are acting opposite to one another. So, opposite direction means what's the formula? F1 minus F2. All of you know. Same direction means you have to add F1 plus F2. Here we are given opposite direction, so you have to subtract. Okay, find the resultant force. Resultant force you have to find out. First, you have to write what is given in the question. First, we have to write solution. Given. What is given? First force F1. So F1 equal to 5 Newton. Next F2 equal to 15 Newton. Now listen all of you, 2 force is given. First force you have to take F1. Second force you have to take F2. Now look at this, F1 5 Newton, F2 15 Newton. Now which force is greater, F1 or F2? Say students, F2 force is greater. No. So here F2 is greater than F1. Now what is the formula? You have learned already. So F resultant force, F resultant equal to, what is the formula? First you have to write F2 minus F1. Can you understand this formula? F2 minus F1. Why F2 minus F1? Because F2 force is greater when compared to F1. Okay. So you have to subtract the value. F2, what's the value? 15 minus F1 value 5. So you have to subtract 50 minus 5, 10. What's the unit of force? Newton. 10 Newton. So F resultant equal to, resultant force equal to, what you will get? You will get 10 Newton. So you write the resultant force of 10 Newton is acting in the direction of F2. That is greater force. Can you understand this problem? Suppose F1 5 and F2 5 means what's the answer? 0. No. Suppose F1 equal to 5 Newton. F2 equal to also 5 Newton. What value you will get? The formula is F resultant equal to, what's the formula? F1 minus F2. So you will get 0. So this we will say as a equilibrium. Okay. So here F2 greater, so here written first F2 minus F1. Suppose here F1 15, F2 5 means what's the formula? F1 minus F2. Can you understand students? Clear it? No. So 3 also very important. Anyway, you have to learn. Okay, this 2 mark question for you. First you have tried to given, after that formula, substitution, answer and unit. Is everything there means only you'll get a 2 mark. Okay, students? Then we can mark the questions. Take your book, all of you. Students, for your worksheet today's worksheet, first question, define inertia. Already you have learned this question. Once again, I will mark today. See, define inertia, give its classification. And the example also you have to learn. Second one, classify the types of force based on their application. So, what are the types of force? Like parallel force and unlike parallel force. Then the third one, what are the effects of force? Okay, first we have mark, define inertia, give its classification. That page number 2. Take all of you. The inherent property of a body to resist any change in its state of rest or the state of uniform motion unless it is influenced upon by an external unbalanced force is known as inertia. Next, types of inertia. Inertia of rest. The resistance of a body to change its state of rest is called inertia of rest. Inertia of motion. The resistance of a body to change its state of motion is called inertia of motion. Inertia of direction. The resistance of a body to change its direction of motion is called inertia of direction. Examples of inertia. So this 3 example also you have to learn. This example, inertia of motion, this inertia of direction, inertia of rest. Okay, up to this much you mark it. This question number, Rome letter 7, question number 1. First definition, types and example you have to write. Rome letter 6, question number 1, definition and types alone you have to write. Okay students, up to this much you mark it. This book inside question, what are the effects of force? Right here, what are the effects of force? Force is an external effort in the form of push or pull. First efforts, it tries to produce the motion of a static body. It stops or tries to stop the moving body. It tries to change the direction of motion of a moving body. Force has both magnitude and direction, so it is a vector quantity. Next one, classify the types of force. This Rome letter 6, question number 2. Based on the direction in which the force acts can be classified into 2 types. First one, like parallel force. Second one, unlike parallel force. Side getting like parallel force. 2 or more forces of equal or unequal magnitude acting along the same direction parallel to each other is called like parallel force. Unlike parallel force, if 2 or more equal forces or unequal force acts along opposite direction parallel to each other, then they are called unlike parallel force. Rome letter 6, question number 2. Now look at this table column. Parallel force are acting in the same direction. So F1 and F2 act in the same direction. The formula is F resultant equal to F1 plus F2. Parallel unequal forces are acting in opposite direction. So see the picture. And the formula is F1 is greater than F2. The formula is F1 minus F2. F2 is greater than F1. The formula is F2 minus F1. Next, the parallel equal forces are acting in opposite direction in the same line of action. So here equal to same force F1 and F2 same force. So resultant you will get F1 minus F2. Resultant is 0. So this only you will say as the equilibrium force since F1 equal to F2. Now if the resultant force of all the forces acting on a body is equal to 0, then the body will be equilibrium. Such force are called balanced force. Mark it, this under book inside questions. Okay. So balanced, what are balanced force? The next one is if the resultant force is not equal to 0, then it causes the motion of the body due to unbalanced force. This what are unbalanced force. What are balanced force? Right there. And what are unbalanced force. This example only video you have to see. So the drawing water from a well, the force applied with a crowbar forces the weight, balance, etc. So any one example you have to write. Okay students, so this much questions, learn well and write in one note. Okay students, thank you.